And this is question 6 in the Assess 19 on page 286. Small question, I'm sure it's got power in it. Right, power pack question. XA is A, alright, and XB is A plus 2B. I've got to find AB essentially. Right, so I want AB. I've got to make sure these vectors poke around the right way. So in order to go from A to B, I've got to start with A. In other words, flip this vector around, which means AX followed by XB. Do you see that? Starting with A, finishing with B, hence AB. Well, AX is going to be the negative version of vector XA. In other words, minus A plus XB. Well, that's straightforward because it's just A plus 2B. Simplifying, minus A plus A. Well, that cancels nicely. You don't have any A's. That leaves us with just 2B. So answer 2. Oops, back to blue, I think. That gives us 2B. So A to B is 2 little b's. That's it. Now part B. YC is 2 C's and YD is this horrible thing here, 2 bracket D minus C close bracket. Find CD. Alright then. So I've got to go from C to D direct, which means I've got to start with C, which means I've got to flip this vector around. So I want CY plus YD. Alright? So C is the beginning, D is the end, and therefore I've got to flip this YC around. In other words, the vector will be minus 2C plus, well, YD is as you see it there in the correct direction, 2 brackets D minus C. I've got to multiply out and then simplify the expression. So that's plus 2Ds and minus 2Cs. That gives me minus 4C's altogether, doesn't it? Minus 4C plus 2D's. It's fine as it is, but let's factorize it, take a 2 out. That will give me minus 2C plus a single D. I'm not sure there's any marks for going this far, but there it is anyway. That's question 6 done. Let's flip over to the other page and look at question 7. Looks a bit involved, doesn't it? Now, I've got an isosceles triangle. That's going to be important later on, I'm totally sure about that. I'm told that AM is worth little a, so they should have really put a little mark for M there, really, shouldn't they? As we don't know where it is on the diagram, so it looks like it's randomly just floating along somewhere between A and C. So anyway, A to M is little a, and A to N is little b. I feel better about that. I've got to find MN. Okay, well that's good. M to N, literally that. Okay, it's not very clear. That to that. Okay, I'm happy with that. Got to find that in terms of A and B. Well, that's not difficult. I need to go from M to N, so I've got to go from minus A plus the B. Straightforward, isn't it? So write it straight in. Minus A. So I'm coming from M to A, then A to N. So that's M to N. So minus A plus B, or B minus A is good enough. Now I'm told that CB is 3 lots of B minus A. So I'm going to write it in. And I think I better write this one here as well. Now I can see the way this goes. I've got B minus A, and this is minus A plus B. In other words, this is also B minus A. Writing it round a way which matches the vector, which is 3 times the magnitude of BA. So B minus A. So I think I've got this set up right. So C to B in that direction is 3 times B minus A, and M to N I've calculated it as B minus A. Alright? So that's that. Find MC and NB in terms of A and B. So it's 2 separate questions. M to C. So I've got to go from M to C. How do you go from M to C? I haven't got a clue. Isosceles triangle. So these 2 lengths are the same. Pause and think. Really easy actually. That's B to A. That's B minus A. That's 3 lots of B minus A. This is 3 times as the magnitude of that. Therefore, from A to M compared to A to C is going to be 3 times A. Because of the way these similar triangles are working out. Remember, it's isosceles, so this little triangle is, if you like, extended to this larger triangle here. So if A to C is 3A, then M to C will be 2a. There you go. A plus 2a makes 3a. In the same way, n to b, well, same ratio, that's going to be 2b. Because 2b plus 1b makes 3b. And there you go. Lovely. Right, find the ratio of am to mc. Well, am is going to be, let's do it down here, I think. am is going to be a, and mc is going to be 2a, and therefore the ratio is 1 to 2. Really easy. And that's meant to look a little bit more like an a rather than a 9. So 2a. And this is meant to look more like an a rather than a 9. A. Alright, very easy. That's that. Now D. Describe the relationship between triangles ABC and ANM. I think I've said it just didn't in my discussion. They are similar triangles. Look at this. We're going to have a common ratio. That's 1 and that's 3. So 1 to 3 ratio. By the way, AM to MC. Yeah, that's a 1 to 3 ratio here from A to N. B from A to B. 3b, so it's a 1 to 3 ratio. Look at this length here, b minus a, 3 lots b minus a. They are similar triangles. If I want to get some extra marks, maybe if it's a 2-3 mark question, expound upon it. So similar triangles, and so triangle A, B, C is an enlargement of triangle AMN, or ANM as they call it, by scale factor 3. So look, if this was a 3-mark question, they'll probably want you to say similar triangles. They'll probably want you to use the word enlargement and give the scale factor. Again, in an exam, you can get these ideas and get those hints by looking at that. And question 8 on page 287 is a continuation of the Assess chapter 19. It looks quite tricky, it really does in places. ABCD is a rectangle, there it is, no problem there. M is the midpoint of AB, so if M is the midpoint of AB and A to M is vector A, that means M to B must also be vector A. Right, it helps. D to C, well, that's going to be 2 A's, isn't it? Because it's a rectangle, and AM is parallel to DC. So put in a 2A there, not worry about it. I'm told that AN is 2 lots of ND. So AN, little baby B, is twice as big as N to D. So in other words, N to D has got to be 1/2 of a B. Is that alright? So 2 halves make the whole, so that makes sense. And that will make B to C. I'll just do a quick vector here, not part of the diagram, just like to remind me for later. So going from B to C there, that's also going to be equal to B plus half a B, 1 1/2 lots of B, or you can call it 3 halves of a B, or 3B over 2, something like that. So I've set up the diagram as much as I can here. Right. Question, find the following vectors in terms of A and B, the usual thing. Alright, by the way, BO equals 3 lots of OC, so OC, if you like, is a third of B to O. So in other words, we've got a ratio of, say, 3 to 1 here, so from B to C, we've got a ratio of 3 to 1. Add up the ratios, gives you, 4 shares, if you like, in that particular ratio. This will come into play quite significantly, I'm sure. But anyways, take it one at a time. Find the following vectors in terms of A and B. M to B, well, that's very easy, we've just done it. M to B is vector A. B to O, well, B to O is tricky. We cannot assume that A to N is the same as B to O. But B, again, difficult questions has just happened now. B to O is going to be, if that's 3 portions and that's 1 portion, it's going to be 3/4 of vector B to C. So let me do the maths here. I'm looking at 3/4 of vector B to C, which is 3/2 of a B, isn't it? Is that alright? I don't need a times there. Just put a B then and be happy with it. So, alright, 3/4. So B to O is 3/4 of the entire length B to C, and the entire length B to C is the same as A to D because it's a rectangle, and A to D is directly parallel with B to C and is of the same order of magnitude, well, the same magnitude exactly. That's going to give us 9B over 8, or 1 and an eighth of a B. A's are not involved at all in this discussion. Now M to O, well, how do I go from M to O? I'll go from M to B and B to O. Now do it here, let's write it fully in case we get lost in the story. M to O is going to be M to B followed by B to O. Alright, starting with M, finishing with O. Substitute, well, M to B is called little a, and B to O, I've just calculated it as 3/4 of whatever 1/2 B's is. Well, 3/4 of that I've calculated it as 9 over 8, so that's going to be plus 9/8 of a B. Alright, so sorry that the A and the 9 looks very similar, that should help a little bit. And D, do it here, I want to go from N to O. In other words, let's just draw it in so it stands out as a question in its own right, which it is. So let's put an arrow on that. How do we do this then? Well, I can go up here, across here, and down here. Well, why shouldn't I do that? I can do that. I could go down here, across, then up, but I won't. I'll go the long way around. I'll go up here. There's no point in working out NM. No point in doing that. And MO, leave it alone. I want to go up here, right the way across, and come down again. So I'm going to fully write it out. NO, it's like going from N to A, followed by A to M, followed by M to B. Of course, you know, A to B is going to be 2 A's anyway, isn't it? And finally followed by B to O. And I know I've done it in a long, horrible way, but look, starting with N, finishing with O, starting at N, finishing with O. Let's shove in the vectors quickly. N to A is going to be minus B. Then I want to go from A all the way to B there, which is plus 2A. Then I want to go from B to O, which is going to be whatever BO was before. B to O is going to be 3/4 of B to C. And B to O was, there it is. So it's plus 1 and an eighth of a B. So what do we got here? That will give us altogether minus B plus 1/8 B. It'll be 1/8 of a B on its own, because minus 1 plus 1/8 gives me 1/8 in the positive direction, plus 2A. I don't even want to factorise that. That looks absolutely horrific. So I'm going to stop there and probably do the AQA question on page 287 as a backup. That also looks rather tricky. Alright, so I'll catch you later.